Hello, welcome to Math 1150. I am Corey Thrush, and we are going to get started with Chapter 1, which is Introduction to Data. And so after I read off these learning objectives, I would stop the video and write these down, because these will be very important and you can go back and review them. So the first one is, first learning objective for Chapter 1 would be distinguish between numerical and categorical variables. 2 is find and use rates, which includes percentages, and understand when and why they are more helpful or useful than counts for describing and comparing groups. The third one is understand what it is possible to infer a cause and effect relationship. Fourth is explain how confounding variables prevent us from inferring causation and suggest confounding variables that are likely to occur in some situations. And 5, be able to distinguish between observational studies and controlled experiments. So section 1.1, what is/are data? Well, the first question while you're taking this class is, what is statistics? Statistics is a science and it's an art of collecting and organizing, summarizing, and analyzing data to answer questions and or draw conclusions. So why do we care about it? Well, statistics allows us to explore the world around us, use evidence to check whether our beliefs are true, and find patterns to lead to discoveries and share new discoveries with others. So keep in mind that this is a very tricky area, so statistics must be used carefully. Inappropriate use will result in inaccurate beliefs, and results are always uncertain. So stats rests on two major concepts. The first one is variation, the differences or changes in an item. So you can see between these two A's here, this one varies from that one, or this one varies from that one. You can say either way. This one seems to be a little bit more slanted on the left side, while this one kind of is slightly slanted but more upright. And then this one kind of goes kind of more straight like a line, which is comparable to this one. And this one looks a little bit more messy, and this one looks a little bit neater. So that's an example of variation. So, and then the second major concept of stats is data. Observations are gathered to draw conclusions. So a few examples of data are some measurements. So like weight, height, distance to BG from where you're living, and so on. Another one could be a number of customers that you have coming into your store. So maybe you want to know how many customers comes into your store on Fridays versus Mondays, and see like how you could maybe bring more customers on Monday rather than have a huge spike at the end of the weekend or something like that. And then another example would be a list of song titles stored on a computer. So notice that data is just more than numbers. So we have 8.32, 7.91, 9.64, and so on. So these data could represent birth weights. So like a baby could weigh 8.32 pounds when they are born. Or this 832 could be how much you $8.32 for whatever lunch you bought for at the cafeteria today. So data is just numbers and context. Like looking at the data, you have to also know the story and context behind these numbers. They're just not just random numbers spit into a data sheet for you. So data analysis is a process of examining collected data to explain what the data tell us about the real world. So an example of this would be like in sports. They're always churning through data. to find the analysis of why LeBron James is better than Kobe Bryant or Michael Jordan. That seems to be a conversation that's always brought up. So that would be an example of data analysis, or there's several ways to do a data analysis, but that's an example of one. So let's start off with section 1.2, which is classifying and storing data. So there's two things you want to know. Is first, the population. That's a complete set of people or objects being studied. Information about the population is usually the goal. However, obtaining all data values from the population is usually impossible. A sample is a subset of the population from which data are obtained. A sample is used to make inferences about the population, and the goal is to describe the population. So that sample should be representative of the population so as to generalize from sample to population. So an example of where you would be looking at sample and population, we're coming up on the 2020 election. So these pollsters identify a population of interest, and it's usually going to be the United States of America citizens, or likely voters, or registered voters, and they draw a sample from that population to answer these questions about, hey, who do you prefer, Biden versus Trump, as an example. Here's an example of some data. So what do these represent? I'm guessing here, this could be an ID number for a poll. This is their name. This is where they live. We need to understand the context of these data. So, and you can understand why that was hard, because I was kind of blabbering through, and I wasn't really sure what these variables meant after this third one. So if we don't know what values are measured and what is measured about them, the values are meaningless. So what information would provide a context? The context ideally tells who was measured, what was measured, and how the data were collected, and where the data was collected, and when and why the study was performed. So going back to the pollsters, we could see, okay, who are we identifying? What do we want to identify? And when do we want to perform it? Where was it done? Why was it done? And how? So to answer these in the pollsters, so who, we want to know, our population of interest is likely voters. So what are we going to ask them? Are we just going to ask them one question, or is there more to our survey other than, hey, who do you prefer, Trump or Biden, or are you a registered Democrat or Republican or independent, and so on? And then when? Well, I mean, they're always doing these polls throughout the year, especially in election years. So that will be very important, because polling from February is not representative of where we are currently in August or September, whenever you may be seeing this video. And then where? Well, I don't think these people are going to go from state to state, so we need to identify where we want to go. Why? Well, to answer the question, why do we want to know who is more popular? So we can gain an idea of who may be winning before it actually happens. And this could be helpful to both the Trump and Biden campaigns, because, hey, if Trump is down, they want to know, okay, why are we down? What are some things that we can do to get us back in the ball game? Or on the Biden campaign, okay, we're ahead, so how can we extend our lead so we don't get complacent? Like, how do we extend our lead more so it could help us in future years? And then how? How was the data collected? Was it by telephone? Was it by going up to door to door? Was it they just asked people who came into a convenience store? These are all needed questions that we need to answer. So who? describes the individuals who were surveyed, what determines what is being measured, when was the research conducted, where was the research conducted, why, what was the purpose of the survey or experiment, and how, describe how the survey or experiment was conducted. So the answers to the first two questions are essential. If we don't know what the values are measured and who those values are measured on, the values are meaningless. So who, which if they're not people, so respondents, individuals who answer the survey, or customers at Amazon, subjects or participants, people who are experimented on. So an example of this would be patients who received a new medication for like a weight loss pill. And then the experimental units, the object of the experiment, when it's not a person, like animals, plants, and websites. So we are always running studies on rats or mice to see how they function and how it could be replicated in humans. So an example of this would be rats that run through a maze. And then records, rows in a database. So each person's purchase record at Amazon. So column titles tell us what has been recorded. Each row is about a particular purchase, and you can see that it's the same data that I had no idea about after this column here. So these are purchase records for album download orders from Amazon. So you can see how I was just guessing, and now we are answering all 6 W's behind this. So Amazon is interested in this data because maybe they can use it to promote music to certain customers while not promoting certain types of music to another customer. So here's an example. Identify the who and what were investigated in the population of interest. So some companies offer 401k retirement plans to employees, permitting them to shift part of their before-tax salaries into investments such as mutual funds. Employers typically match 50% of the employee's contribution, up to about 6% of salary. One company was concerned with what it believed was a low employee participation rate in its 401k plan. So they sampled 30 other companies with similar plans and asked for their 401k participation rates. So I would suggest to pause the video and be able to answer this question in your notebook. Alright, so what were your answers? Was your first answer to the who that they wanted to investigate 30 similar companies? And then the what was the 401k employee participation rates? And the third one was the population of interest, which was all similar companies. So variables. These are the characteristics recorded about each individual. That's called a variable. So the order number, the name, the state/country, the price, area code, and previous album download, and was it a gift, are all examples of variables. So we have numerical or quantitative variables. They're the same thing, which describes the quantities of the objects of interest. And these contain numerical values with measurement units. So quantitative data represents a quantity that can be measured, how much or how many of something is present. So a couple of examples of these we talked about earlier: weight, height, price of an object, and so on. Well, categorical or qualitative variables are a variable that describes qualities of the object of interest. It tells us what group or category an individual belongs to. So these categorical variable values are usually not numbers. So examples of these are gender, eye color, and country of birth. And then more examples: telephone area code or zip code, categorize each phone number in a geographical region. So which of the following variables are qualitative and which are quantitative? I would suggest to pause the video and answer these questions. So A will be quantitative, because age is a numerical value. So the official reason behind it is this variable is quantitative because it tells us how much time has elapsed since a person was born. A person's gender, is that qualitative or quantitative? It's qualitative because it consists of the categories male and female or other if you decide to identify as a different gender. C, the mileage of a car, is quantitative because it tells us how many miles a car will go on a certain amount of gasoline. And then the color of a car, that's going to be qualitative because it consists of categories of different colors. Colors can't, they're not a number, it's clearly going to be categorical or qualitative. So here's another example. Identify the W's, name the variables, and specify for each variable whether its use indicates that it should be treated as a categorical or a numerical variable. So a listing posted by Arby's restaurant chain gives, for each of the sandwiches it sells, the type of meat in the sandwich, the number of calories, and the serving size in ounces. The data might be used to assess the nutritional value of the different sandwiches. So I would pause the video and work on this example by yourself. So first let's identify the 6 W's. So who, Arby's sandwiches, and what, the type of meat, or the number of calories and the serving size. When, well, it's not specified. Where, it's going to be Arby's restaurants. Why, well, these data might be used to assess the nutritional value of the different sandwiches. And how, information was gathered from each of the sandwiches on the listing. So there are 3 variables, and the number of calories and the serving sizes are going to be numerical variables, and the type of meat is going to be categorical, because meat's not a number. It could be ham, it could be roast beef, it could be chicken. So I hope that makes sense. Okay, here's another example. Let's identify which of these variables are numerical or categorical. So first let's start with the numerical variables. So we have age, gender, major, units, housing, and GPA. So age, there's numbers, so that would be a key indicator that it's a numerical one. But not always. We'll talk about this later. Units, there's numbers in it, so that's going to be another numerical variable. And then finally we have GPA, because that also has numbers, so that's also going to be a numerical variable. So categorical variables, well, gender, because male, female, or other is going to be a category. Major, because major, it's clearly you can like cluster people into a major, like psychology or business. And then housing, well, this is also going to be categorical because you can't enumerate housing. It doesn't make sense to quantify it. So we are housing would be the last example of a categorical variable. So let's talk about coding. So let's just say these are the results we got from a survey where we supplied it to undergraduate students at BG. And the answers go from personal growth to career opportunities, parental pressure, and personal networking. So we have all these results. So personal growth, 4 personal networking, 3 parental pressure, 2 career opportunities. So the reason for coding is because it's easier to input into a computer and to analyze it. And then coding with the categorical data, although the above data values are numbers, these are clearly going to be categorical variables because personal growth is not an example of a quantitative measure. And same with personal networking. So you can see that's still going to be categorical, even though it is coded as a number. So let's just say we have a survey of yes and no questions. So we could use 0 for no and 1 for yes. But this could also be useful for data with only 2 possible values. Another example would be true or false, black or white, success or failure, or dead or alive. So storing data. Stacked data is data stored in a spreadsheet style format, so like Excel. Each row contains several characteristics of an individual, so each column represents a variable, and stacked data can store many variables. So we have name, age, weight, and height, and this would be an example of stacked data. While unstacked data, you can separate from stacked data, which you'll see down here below. So it's data stored such that each column represents a variable from a different group. So a single variable is broken into different groups, and unstacked data can only store 2 variables: the variable interest, like time or height, and a categorical variable, like gender, that tells us which group the observation belongs in. So here's examples of unstacked data where we have the race times for men, and then we have the race times for women. So we could easily convert this from stacked data to this. And then another example is men's heights and women's heights. We could clearly take this out of a stacked data set. So that is going to be it for section 1.2. The next video will have the rest of chapter 1. Thank you for watching.